So this learning target is I can use the concept of half-life to solve problems. Half-life. So this is the key vocabulary word in this learning target. What do we mean by half-life? Well, the definition of a half-life is basically how long it takes for half of a substance to decay. So more specifically, it's the amount of time it takes for half of a substance, and we'll be more specific, we'll say of a radioactive substance, to decay. So since it's the amount of time, the units for a half-life will be units of time. So things like seconds, or minutes, or days, or sometimes even years. It depends on what the isotope is. Some isotopes decay very slowly. They have half-lives of years. Some decay very, very fast and have half-lives of seconds. So what do we mean by this visually? Well, here's a graph that shows at time 0, when no half-lives have happened yet. You just have, let's just say you have a jar with a bunch of atoms in it, and you know they're radioactive at the start. And let's say you have 100 atoms in that jar. Every single one of these red circles represents a radioactive atom. Okay? And we know that since these atoms are radioactive, they're going to decay. They're going to break down into smaller atoms. So after one half-life, we know that half of those atoms are going to decay. So well, half of 100 is going to be 50. So we can see here after one half-life, we now have 50 atoms. Well, what happened to the other ones? Well, as you can see in the diagram here, half of those atoms are still red. Here are the red ones here. They're all still the same radioactive atom. But half of them have decayed. They've turned into another atom. That's what we see with the gray circles. So these represent the atoms that are decayed. So these are our daughter isotopes. Okay. Then we know over time, after another half-life, however long that may be, we don't know yet, half of these 50 atoms are going to decay. So half of 50 is going to leave us with 25 atoms. So as we can see in this diagram now, half of these red circles are gone. They've turned into gray circles because they've decayed. And then we know after another half-life, half of those 25, which is going to be about 12.5, are going to decay. So now look, we have so few red atoms left because the majority of them have decayed over time. So conceptually what you need to recognize is that when something decays, it doesn't disappear. It just turns into a different atom. So how can we apply that to actual problems? Well, here's two examples. Number one, the half-life of zinc-71 is 2.4 minutes. If one had 100 grams at the beginning, how many grams would be left after 7.2 minutes has elapsed? Well, let's break this down. What are we starting with? We're starting with 100 grams of zinc-71. So 100 grams. Okay. We know that the half-life of this substance is 2.4 minutes. So we know after 2.4 minutes, half of this stuff is going to decay. So if we had 100 grams to start, half of it's going to decay, we'll be left with 50 grams. Then we know after another half-life, 2.4 more minutes, we know that half of that 50 grams is going to decay. So we're going to have 25 grams. And on and on. After 2.4 more minutes, we're going to have half of 25 grams. So half of 25 would be 12.5. And then we know on and on. After another 2.4 minutes, we'll have half of 12.5, which would be 6.25 grams. Okay, we could do this forever, but we got to actually answer the problem. It's asking how many grams would be left after 7.2 minutes. Well, let's think about it. So this process took 2.4. This took 2.4, so that's a total of 4.8. Then another 2.4, well 4.8 plus 2.4, that's going to be 7.2. Ah, there we go, after 7.2 minutes. So after this time has happened, after this time has happened, and this time has happened, how much is left? 12.5 grams. Let's try another problem. 100 grams of an isotope with a half-life of 36 hours is in a sample. How much time will have elapsed when 5 grams remain? So let's think about what we're starting with, 100 grams, okay? It's not always going to be 100 grams, it is in these two examples. And we know the half-life is 36 hours. So after 36 hours, we're going to have half of that 100 grams left, so we'll have 50. Then after another half-life, another 36 hours, we'll have half of that. So that would be 25 grams. How far do we need to go? We need to get until we get to 5 grams left. So 25, we can, and I apologize, there's a slight typo. This should be 25 grams. There should be 25 grams remains. So what we can see here is we've gotten to 25. Now we got to figure out how much time will have elapsed. How long did this take? Well, this step took 36 hours. This step took 36 hours, so the total amount of time is 72 hours. So there's the concept of half-life. Review these two problems, see if you know how to do them, and move on from there.